I'm going to pre-tin this motor wire. I'm just going to melt some solder onto it so that it gets a good connection. And I'm going to make sure that it's coated really well on both sides. Just heat it up some more and let it flow really good into that wire. And get the sides. I've got the wire held in place with the helping hands tool. And I just come under here and melt all the solder and put some more solder on top. That smoke that's coming off there is the flux that's in the solder. You don't want to breathe that. It doesn't smell very good anyway. When I solder on the Dean's plug, I want to be careful to observe the polarity. So you can see there's positive right there, and then the other side is negative. Got to wire this up correctly or the motor will run backwards. Also, I'm soldering the female Deans to the speed control, because if I were to solder the male Deans to the speed control, there's a possibility that the battery might get hooked up to the wrong connector on the speed controller. So here I am pre-tinning the actual Dean's connector. That will give a better, a stronger connection. So I'm ready to solder the wires to the Dean's plug, and notice I have the heat shrink on the wires, and that's very important. So I'm going to put some extra solder on the iron, and then I'm going to put the Dean's wire, speed control wire rather, on top there, and melt the two together. Now when I was soldering, I had a male and female Dean's plug. Actually, they go this way. I had them plugged together. The directions say explicitly not to do that, but I have seen professionals do it this way, and it made it easier for me, and I did not damage or destroy the plug by doing it. This job's all done. I used a heat gun to kind of melt the heat shrink tubing over the soldered connections. So this is ready to plug together and test. So it goes forward. When I make it go forward, it goes reverse. It's got brakes. So it's a job well done.